A breakdown of the levels of autonomous driving. A breakdown of the levels of autonomous driving. Rapid developments in technology are radically changing the automotive industry, including the arrival of autonomous cars. The advent of autonomous cars has captured the imagination of tech enthusiasts and industry insiders who eagerly await the day when self-driving vehicles become a reality. But what do we mean by autonomous vehicles? In what ways are they different from traditional cars? How do they work, and what are the different levels of autonomy? In this article, we will break down the levels of autonomous driving and explore the technology that drives this innovation. In simple terms, autonomous cars are vehicles that can operate without human intervention. They rely on a combination of sensors, cameras, software, and mapping technology to navigate roads, identify obstacles, and interact with other cars. The ultimate goal of autonomous cars is to reduce the number of accidents on roads and to make driving more efficient and convenient. Let's explore each level in more detail. Level 0, no automation. The lowest level of autonomous driving is Level 0, which refers to traditional cars that require a human driver to operate all essential controls, such as steering, braking, and accelerating. There is no automation in Level 0 vehicles, which depend entirely on the driver to ensure safe operation. Level 1, driver assistance. Level 1 autonomous cars feature basic automated functions that can make driving easier and more convenient. However, despite these automated features, Level 1 vehicles still require the driver to remain in control of the car and monitor driving conditions. Level 2, partial automation. Level 2 autonomous cars feature more advanced automated functions that can significantly reduce the driver's workload. In addition to the basic features found in Level 1 vehicles, Level 2 cars can control their speed and steering in certain situations. For example, a Level 2 car might be able to accelerate, brake, and steer on highways, but the driver must remain ready to take control at a moment's notice. Level 2 vehicles are more advanced than Level 1 vehicles, but they still rely heavily on the driver to remain alert and attentive. Level 3, conditional automation. Level 3 autonomous cars represent a significant jump in automation from Level 2 vehicles. They are capable of operating under specific conditions without human intervention. For example, a Level 3 car might be able to drive itself in traffic jams or on highways, with the driver able to take their hands off the steering wheel for extended periods. However, unlike Level 2 vehicles, Level 3 cars can alert the driver when conditions require them to take control. Level 3 cars require the presence of a driver who is capable of taking over control at any time. Level 4, high automation. Level 4 autonomous vehicles have a higher degree of automation than Level 3 cars and represent a significant advancement in self-driving technology. They are capable of operating under most conditions without any human intervention. Level 4 cars can drive themselves on highways, in cities, and other specific environments without the need for driver intervention. Unlike Level 3 vehicles, Level 4 cars do not require drivers to remain alert and ready to take over at any moment. Level 5, full automation. Level 5 autonomous cars represent the highest level of automation and require no human intervention under any driving conditions. Level 5 cars are capable of driving themselves in any environment without a steering wheel, pedals, or any other traditional driving controls. Despite the vast potential of Level 5 vehicles, there are still significant challenges that need to be addressed before they become a reality. Some of these challenges include regulatory hurdles, safety concerns, and technological limitations. As the industry moves towards more advanced levels of autonomy, it is essential for regulators and technology developers to work together to ensure the safe implementation of self-driving cars. Regulators must establish guidelines that ensure the safety of both the passengers in autonomous cars and other road users. Technology developers must create systems that are reliable, secure, and easy to use. One significant benefit of autonomous driving is the potential to reduce the number of road accidents. According to the World Health Organization, WHO, approximately 1.35 million people die each year in traffic accidents worldwide. Moreover, autonomous driving has the potential to revolutionize the transportation industry. Self-driving cars could reduce traffic congestion, improve fuel efficiency, and reduce transportation costs significantly. In addition, the elderly and people with disabilities could benefit significantly from self-driving cars, as they would not be limited by their ability to operate a traditional vehicle. As the technology advances and becomes more widely adopted, the question of liability and responsibility will become increasingly important. If a self-driving car is involved in an accident, who is responsible, the driver or the vehicle manufacturer? Autonomous driving raises new legal and ethical questions for society to consider. In addition to the benefits mentioned in the previous section, there are also potential environmental benefits of autonomous driving. Self-driving cars could reduce emissions by optimizing routes and minimizing idling time. They could also encourage the adoption of electric and hybrid vehicles, as self-driving features could help overcome the concerns of range anxiety and charging infrastructure availability. Furthermore, the development of autonomous driving technology could create new job opportunities in the tech and transportation industries. For example, the increased demand for sensor technology and mapping services could create new jobs in the tech sector. The need for maintenance, repair, and upgrade services for autonomous vehicles could also create new job opportunities in the automotive industry. However, there are also concerns regarding the impact of autonomous driving technology on the job market. With the increasing automation of driving tasks, there is a risk that jobs in the transportation industry, such as truck drivers and taxi drivers, could become obsolete. It is essential for policymakers and industry stakeholders to consider the impact of this technology on the labor market and develop strategies to address any negative effects. Another consideration is the privacy implications of autonomous driving technology. Self-driving cars collect vast amounts of data, including location data and driving behavior, which could be used by third parties for marketing or surveillance purposes. It is essential for regulations to address the privacy issues of autonomous driving and ensure that users have control over their data. Finally, there is the issue of cybersecurity. Self-driving cars are vulnerable to cyber attacks, which could compromise the safety and security of passengers and other road users. It is essential for autonomous driving systems to have robust security measures to prevent hacking and ensure the safety of users. Moreover, it is worth noting that autonomous driving technology is not limited to passenger cars. Self-driving technology can also be applied to trucks, buses, and other commercial vehicles. The potential benefits for the transportation industry are enormous, including increased efficiency, faster logistics, and reduced costs. For example, self-driving trucks could reduce labor costs and increase efficiency by operating continuously, without the need for rest breaks or shift changes.